you'll notice this is pretty much the same kind of problem as we did in examples 1 and 2. All right, but there's something I did a little differently about it. It'll pop up right away. All right, the first thing you're going to notice about this guy. All right, and I'm going to actually do this calculation and then erase it. All right, first thing you're going to notice is that you're not given molarity. You're not even given moles. You can't just divide moles by the size of the container. You're given grams. Now that's not a big deal. We've dealt with this before. Okay, so what do? If I have 14 grams of carbon monoxide placed in a 2.5 liter container, I want the molarity. What am I going to have to do with the 14 grams? Convert it to moles. Yeah. So do this, but you guys are going to want to do it. I'm going to do it down here and erase it. You're going to want to skip yourself about, I don't know, maybe either do it to the, no, you can't really do it to the side. Skip yourself about 6 or 7 lines because you got to do the ICE and then the equation. So I say 6 or 7 lines. Okay. You want to skip, and then we're going to do this conversion. I'm going to erase it, so I'm not going to skip those lines. All right, so 14.0 grams of carbon monoxide I have to convert to moles and then divide by the size of the container. Now I made the numbers nice and easy so I can do this one quickly. Grams in the bottom, moles in the top. 1 mole contains, how would I get that many grams of carbon monoxide? I'd add up carbon and oxygen, which comes out to be about 28.01, around 28, basically. And the reason I did that is so you get a nice easy number to divide, which is what? What do you get? 14 by 28 is what? Basically half, right? Yeah. So 0.500 moles. Okay? 0.500 moles, however, that's only moles. As a 2.5 liter container, I divide that by 2.50 liters, and I get, again, another easy calculation. What's 0.5 divided by 2.5? Yes, you do.
0.25.
0.2.
Too hard of math.
All right. Well, again, even if you didn't see these in your head, which you should, you can obviously just do them on a calculator, and you get 0.20 molar. So there's your first problem with this one. It's different. I actually gave you grams instead of giving you moles or molar. Okay. So now that I know this point, I told you you're going to erase it. That was 0.20 moles of carbon monoxide. Where's carbon monoxide up there? Which one's carbon monoxide? Yeah, and that's your second problem. I'm told I have that much carbon monoxide, and that's what I put into my empty container, which means I have none of this at the initial stage. So there's my ICE. Now, I know what people will do. We have, for the first 2 examples, and for the homework that you may have worked on already, always have minus x, plus x. Can that possibly be the case in this case?
No.
No. This is what I'm trying to tell you. By the way, this leads into next period's problems. You're not always going to go forward. You're going to sometimes go reverse. And in a case like this, it's obvious which way you're going. Like it was obvious that you were going forward last time, it's obvious you're going reverse. Minus 2x, plus x, and plus x this time. It will not be so obvious next period. What if I gave you, 0.2 and 0.17 and 0.14, and you had a little bit of everything thrown in there? Which way is he going to go? Well, you have to do something called, solve for the reaction quotient. And I'll show you how to do that next period. But for now, and all the ones you have up there for homework, this is the worst it'll get to. Okay, most of them are going to go just that way. I'm going to put in reactants, and it's going to go forward. But if you get one that goes reverse, or if you get one that has grams, you now know what to do. Now let's finish this guy up just as a review of what to do for the rest of these problems. I've got 0.200 minus 2x, x, and x at equilibrium. Everybody agree with that? And then I write my equation. If you want to get full credit, here's what I want for the work. Kc equals products over reactants. CO squared over CO2 times C.
Wait.
Products over reactants.
That's still the product.
Absolutely. That's the same question I got for Shania, and I didn't yell at her. I actually thought it was a good question. Look at, just because I put in products to this equation and it went reverse does not mean that I've changed. I'm going to somehow rewrite the equation and flip it around and have that guy be the reactants, because I gave you the Kc for that equation. That equation is these guys are the reactants. And remember, that equation uses Kc as forward over reverse, products over reactants. So you have to use it as products over reactants this way, right here. Okay? So you don't reverse it just because I added products and not reactants. I know it seems weird, but you got to remember, products and reactants are kind of an arbitrary thing when you have a reversible reaction. Okay? All right. Good enough. Now, I've got this guy set up. I want to tell me everything I know. I know Kc is 10. I know CO is 0.200 minus 2x quantity squared. And I know these guys x and x. Now, why did I do it this way? Why did I tell you this was an easy one? Well, let me stop right here for those of you who don't remember from yesterday. Some of you are probably thinking to yourself, okay, now I got to square that binomial, first, outer, FOIL, all that stuff. No. Why not in this case? And you will have to do that. And you will have to use those graphic calculators for many of the problems in the on the homework. Not the first one, but for many of them. Why not this one?
Is it x squared on the bottom?
Because it's not just because it's x squared on the bottom. Because it's a square root on the bottom and the top. They're both perfect squares. So I can take the square root of both sides. Okay? Well, let's do that over here. Square root of 10 is, I need a calculator, so let me do that. 3.16? 3.16 equals square root of 0.2 minus 2x quantity squared is 0.200 minus 2x. And the square root of x squared is just x. So there's your equation. I simply took the square root of both sides. Makes it easier. We don't have to do the long calculation with the quadratic formula. What am I going to do next? Cross multiply, right? Okay, so I'll get 3.16x equals 0.200 minus 2x. Now I got to combine like terms. What side should I bring my x variable to? Left or right? To keep them positive. I want to keep them positive. I want to bring them to the left, right? That'll give me 5, because negative 2 will be a positive. I have to add 2x here, add 2x there. That's 5.16x equals 0.200. What does x end up equaling? And by the way, very good mistake made last period. I want to fill you in on it. Somebody accidentally plugged it into the calculator backwards. 5.16 divided by 0.2 got like 28 or something like that. How would I know 28's wrong? Yeah, if I plug them into this equation, 0.2 minus 28, I get a negative concentration. I would know that was wrong right away. So do the 0.2 divided by 5.16. What do you get? 0.039? Okay, so x equals 0.039. Well, it should be three significant figures, so 0.0388, 0.0388 molar, which, by the way, is the answer for the concentration of both CO2 and CO. So that equals CO2's concentration and CO's. What's the only one you'd have to solve for at this point? CO's. I'm sorry, I was wrong. I said CO's. This is just C's. This is just C's. CO's would be 0.200 minus 0.0388 times 2. Minus 2 times 0.0388, right? Because it's basically this equation right here. Got it? See where I got that from? This is carbon at 0.2 minus 2x. 0.2 minus 2x, x is 0.0388. What do you get for the CO then? What is it, 0.122? Okay, I'm assuming that's right. And even if it's not, I was saying to somebody else who had some questions yesterday afterwards, they were ahead of you guys. Some of those in the problems tonight, 44 to 47 tonight, they're going to be, you know, pretty, well, a lot of FOIL and all this other stuff, a lot of algebra, a lot of places to make a stupid mistake. You know, and then they couldn't get exactly the right answer. But I was following and trying to find where they made mistakes. Now, look, this is why you got to show me this stuff. If I see your equation written down with the correct exponents, this is what people forget all the time, the exponents and so on. And I see that this has got, you did it right here, and your mistake is somewhere in the middle of all the algebra. It's going to be like very minimal points off. Problem worth 10 points or something like that. You might lose a point or two. All right. So you show me all of this, and you show me all that work. If the problem is a small math problem along the way, but you've shown everything correctly, you're not going to lose a lot of points. All right. Just make sure you do. Even if, like, say for example, you're in the test, you're running out of time, and you get a number that doesn't seem to make sense. Still plug it back in, so I know you knew to plug it back in and solve for those. All right, so I know that you knew what to do with it. All right, that way I can give you more points. But if your mistake is just an algebra mistake or a math mistake, not a huge mistake, like forgetting a coefficient or an exponent or not using it correctly or making this negative and positive, those are big mistakes. It's going to cost you a lot more points. Got it? All right, let's get to work.